Hello, creators and makers. This is the Random Engineer. Today we're going to continue with our assembly series, doing some more interesting stuff, uh, making a little mechanism that you can use to showcase something in the palm of your hand. So probably I'll have to do this in 2 videos. In reality, I just want to show the actual mechanical mates, but if I feel like doing the complete mechanism that I'm thinking of, I may do a second part of it. Without further ado, let's jump right into it. So, sorry, I didn't mean to do that. I want a new assembly. So you can create assemblies without having to have parts. So also, I'm just gonna use some pre-designed tools that are on the SolidWorks toolbox. If you don't know where that is, you can just go here and in options, you next to the gear, you find a little arrow and say add-ins and go SolidWorks Toolbox Libraries, SolidWorks Toolbox Utilities. So just click OK and you will have something coming up. Just accept that and you'll be good to go. So I'm just going to give it a little name for this. I'm just going to say mechanism. Yep. And right here on your right hand corner, top corner, you'll have something that's called design library. You usually use this stuff to put some parts or assemblies or features that are really useful to you, or you use them a lot. And just below that you have the toolbox. So within the toolbox we have some other formats like the ISO standards and ANSI metric and inch parameters. So for now I'm just going to use the NC inch just because this has more power transmission components. So you see here I'm going to click into gears and I will just drag one. So as you can see, you find some parts and you can define it right over here. So let's say half an inch of the diametral pitch, number of teeth, pressure angle, and let's say nominal shaft. Let's go to maybe 1/4 of an inch. No keyways, and probably just change this a little bit. Yeah, there you go. So this is probably too big. So I'm just playing with it right now because I really haven't I haven't chosen a gear yet, but let's just use this for now. So as you see, I just created a gear with those characteristics without much effort. So if you ever want to change this, you can right click here and say edit toolbox components, and you can go back and keep doing it. All right. So now that we've done this, I just want to create a assembly sketch. The difference between assembly sketch and a part sketch is the assembly sketch is usually used for referencing, and yeah, it's mainly used for referencing. You cannot use it for extrusions within the assembly. So you can also use them for assembly assembly features like component patterns and maybe cuts and fillets and stuff like that, but not for extrusions or adding material adding. So Yeah, I'll just probably, oh yeah. So I'm gonna create a sketch, assembly sketch in the shop plane right here. I will use this one later. So I'm just gonna go sketch, sketch, and create a, doesn't matter how big this is, I'm just gonna create it. So this is a circle, 40 mil circle. So as you see, this sketch is below the mates, so that means that's an assembly sketch. If I were to edit this part and create a sketch within this part, that will be a part sketch, and it will not be shown here unless you click on here and go within the part to show the sketch. So the reason I did this is just to separate it to roughly where I want it. And also now I'm gonna grab a rack, which is gonna be this one. I think I used 6 on the other one, with the same pressure angle, pitch height, maybe 1, no, maybe 0.5. There you go, that looks better. And I just want to make sure that I use the right components here. So I'm just gonna edit and look into this. That's 8 and 20. Yeah, we should be good. Yeah, that's 8 and 20. Yeah, seems like everything is going according to plan. All right. So remember I told you I was going to show you some more in detail about the mechanical mates. So for now I'm just going to create some basic mates, which are top plane, well, the Keynesian mates there. I'm also going to create a, yeah, that's the middle. Okay, I'm going to create a symmetry mate just to keep it in place. So I go advanced mate, symmetry, and choose these two faces. And probably just to have a little change, I'll have these two faces. So they are in the center. There you go. And now, as you can see, I have defined this part and this part. And now I'm just going to give it an advanced mate, which is going to be the distance mate, the minimum 40, and the maximum of the length. I don't quite remember how much that is, so I'm just going to say 60 for now. So the overall length is 6 inches, I take it. So I go back to the mates. Oh, you didn't create it. Yeah, you didn't create it, so I'm just gonna do it again. So right plane, mate, and this face. So that was 6 inches. So 40 mil and 6 inches. Yep. And these are the two faces. So it's not 40 mil, it's probably 20 mil. And I'm gonna set it to 20 as it again. And this is it. So this will go, if I look at it from the front, this will go from there to about there. So now I've completely defined the movement of this rack. Just gonna save it so we don't lose it. Yep. And in this case, it's probably a good idea to put something that keeps the gear in place. So yeah, let's just create it. So this, I'm gonna show you now a new way of creating parts. You go down here in the black arrow and say new part. The difference with creating going new component part like this, like we were used to doing before, is that you can create a new part within the assembly, and you can select the references from the assembly. So right now I'm going to go part, and then even it may happen, it may seem that it's going to happen, but it's just asking you for a plane. So that's the plane that you're going to create your sketch. So in this case, I'm just going to go that plane. So for now, I'm going to create this shape, which is going to be roughly 70 by 50, right? And I'm going to convert entities of this. I'll show you what's the good thing about converting entities now. And I'm just going to create two lines, make them equal, and for construction, so they are not taken into account while building this. And I'm going to extrude it in the features and just say probably 15. There you go. It's all good. So now, why did I convert entities? Because I didn't know where to put this one. So if I update the geometry here, you see how everything updates automatically. Oops, sorry, it's this. So it's that or Control B. So I'm just going to say Control B. And the only reason that's moving with the part is because the part itself has the references that the sketch itself is referenced to these two parts, to the rack on the bottom and to the position of the hole in the sides. So you know that one part is referenced when you have this arrow right here. That's just going to show you, it's telling you that it has some relationships with other parts that are outside of the part itself. All right. So the only reason I did that was because I didn't know exactly where I wanted this part to be. So probably I'm just gonna leave it there for now. Maybe there should be good. All right. So with gears, I usually don't like to just go ahead and put it wherever I feel like, because if you have a really long rack or a really big number of teeth, you'll find that if you do it just by eye, you'll have some deflections along the whole length of the movement. So what I like to do is go to move component and say collision detection. Then say stop at collision and say within these two components, because if you have a big assembly, you don't want everything to calculate, you just want those two features to calculate. So I'm just going to say resume drag and drag it. And now that it's hit something, it just stopped there. So I'm good with that. I'm gonna fix this one for now. Well, yeah, I'm gonna fix this one for now. And as you see, this cannot move anymore. So I'm gonna create an axis here, which is gonna be that one. Just because I wanted to show you another way of making axis, because you really didn't need to. And I'm going to float this one and say these two, sorry, that face, that cylinder here, and that axis there are concentric. And I'm now going to define finally the shape of this. So, sorry, the position of this. So I'm just gonna say from there to there. I'm gonna go and say a distance, and you see SolidWorks automatically sets the distance to what it was. So I'm gonna do that. You can drag it and see if something moves, and nothing moves, so you should be all good. I'm gonna hide the axis, and this should move now. So I just dragged it and put it in another place, right? So you can go Control Z to put it to where it was. But now I'm gonna do something a little bit more interesting. As you see now, this has got some interference there. So that's what I meant by you have to be careful where you put your positions. So I'm going to delete this again. Oh, sorry, never mind. I'm going to suppress this concentric mate again, so this can move back again. There you go. Also, I'm gonna fix this so this doesn't move for some reason. It's gonna tell me there's a mistake there. Just going to suppress it so there are no problems there. And I'm gonna use this plane right here. So remember I told you could use mates just for positioning? That's what I'm gonna do now. So I just chose any sketch that goes through the gear. I'm gonna say advanced mate symmetric, and I'm gonna choose these two planes, and you see how it aligns automatically. So go yes, and now since I don't want to move it anymore, I just want to pull it down. I will go right click and move with triad and drag in the Y direction, just about there. So now I'm gonna create the concentric mate again. I'm gonna delete this mate because this has changed already. Say okay. Okay. So now that that's done, I'm going to create a, I don't remember the name of it. It's a rack pinion. So it's gonna it's just asking me for the rack, which is that one. Pinion, it's this one. So it's just you can choose between pinion pitch or rack travel revolutions. Usually, if you select the right things, it would do it automatically. But I believe I did something. I chose something different. So now, if I drag it, oops, sorry. I'm just gonna fix this. Yeah, I'm gonna fix this. All right, now. Okay. Oh yeah. So whenever you create a new part, you'll get this automatic mate here. That's just letting you know that that's not going to move anywhere. So now that this component is fixed, that means I can move one and not the other one. All right, so we try it again. Mechanical mates, rack pinion, select the rack, select the pinion, say OK. Now as I drag this, the other part should move. But it doesn't move just because, oh no, this should move. Get rid of this. There you go. So as you see, it's not perfect, and that's because I chose other parts. So I'm just gonna put it back to how it was. And just look into this and see what's the pitch. So that's 8 inches. I'm gonna edit this, say 8 inch. Oh yeah. Yeah. So do that. Go back to have the same position as I meant it to. There you go. Edit this and change this to have it over there. Okay, I guess I have to do it how it's supposed to be done. So I'm within the gear itself. I just want to see. There you go. I'm gonna show this, and if you double click it, you'll probably see the pitch diameter here. That's root diameter. What's the pitch one? Overcut. That's a pitch one. Okay, so the pitch diameter is the one that's over here. Yeah, the one, no, this one. So now I can define my rack. Oh yeah, I need to show this one as well. So obviously, if you're making your own, there it is. I'm just going to show. So if you're making your own rack and tooth, and rack and gear, you'll have yourself all these parameters right here. At least you should have them. So now I can properly define where this starts and where this stops. So I'm gonna edit this, delete that, and for the rack I'm gonna click on here, and the gear I'm gonna click on here. There you go, all good. So I'm gonna hide the sketches now, suppress this, and this moves the other way around. So to fix that, you go reverse, yes, yes, and now you see how everything works. So just to keep it nicer, I'm gonna suppress this for now, drag it a little bit like that, and do the same trick. Collision detection, stop a collision between these two components, resume the drag, and make a collision. Go yes, unsuppress, and it still doesn't want to do it. Okay. So it seems like I have to change this. Oops, did something different. Okay, So that's right. Just gonna drag it a little bit just to show you what I mean by fixing and floating. So I'm gonna, so that's fixed now, I guess. Yeah, now that moves. So I'm gonna show this sketch so I know where it starts. And probably just drag a little bit to the left. So suppress that one too. Now, to completely define it, I'm gonna say this line, construction line, and this one has to be tangent. So wait, it won't allow me to do it. Oh yeah, I forgot, I need to suppress this. So now I can freely move this and say that and that will be tangent. Sorry guys, I just need to find my way through this. So I'm gonna delete this rack pinion made here, delete this concentric here, just put it to where I want it to. Also, I'm gonna create that one back again. I'm gonna do it faster this time because I already showed you how to do it, and I don't want to waste your time either. Here we go. Fix this for now. Skip it there. And I'm going to create another plane here. No sketch, sorry. It's going to use the same reference as the other one. And say these two lines. Oh, okay. See what's going on now. Okay. So I just created a new sketch. I'm going to edit the sketch plane. I'm going to say this one. So the whole sketch moves to that plane. Hopefully I can now do it. Still cannot. That is really weird because you should really let me do a tangent, because this is a line and that's a, yeah, that's a construction geometry. Okay, I'm just gonna drag it off to where it is. Delete this one because I don't need it. And create a rack pinion again. Okay, so the rack, this one, pinion, this one. We'll do it automatically. Fix this one. Make these two concentric. Now I can suppress this, float this, Oh yeah, and this symmetric one. And now it's doing it the other way around, so I just edit this, reverse back again, and now I should be good, finally. Sorry about that, just had to think a little bit more about it. So yeah, this now moves. This can be moved by your own hand and whatever you'd like. Sorry to have you guys in such a long time just not doing anything. Okay, so now that that's done, I'm gonna edit this part and create a assembly feature. Assembly feature, oh no, not assembly feature yet. So I'm gonna create a new part, maybe the same hole size as this one. I'm gonna say 6. So 6 mil here, maybe 5. 5 will be better. And create a slot. From there to there, say 5 here too. Just call it 70. And maybe have another one of these. And extrude it a little bit. Hopefully you guys can see what I'm doing now. I'm just gonna name this, and I'm gonna link it here. Well, put it here. So I'm gonna make these two faces coincident. Here you go. Maybe short, maybe smaller. Let's make this 3.5 and this one 3.5 too. There you go, that looks better. And let's say from there to there. Not concentric. Maybe just say from center distance of 5, 3.5 back again. There you go. So by doing that, I'm making the center distance between those two faces 3.5. So right now I'm just going to create another part. Just gonna think a little bit about this. I'm going to edit this part. Oh no, not yet. Seems like it won't let me do it. Alright, so what's going on now is that since these parts are just for read-only parts, if you're gonna edit them, it's gonna ask you to change them. So I'm just gonna save them somewhere else. And now I can edit this part and say I'm gonna create just something like that. Say from there to there. Okay, now that I created that, I'm gonna open this and you see my sketch that's here. So now I'm just choosing the points. Say I want that vertical and maybe just 0.2 inches out. No. let's say 0.4 inches. Not too much. 0.3 inches. There you go. That looks about right. And extrude it just a little bit. So now you can probably see what I'm trying to do. Now I can delete this mate because I already have some other reference, and say this and that have to be concentric. And now as I move this, the other part will move too. Hopefully you see how that works. All right, it's working. So I'm just gonna put it about 180 degrees. So if I move the whole, probably from there to there, have the maximum distance traveled. Okay. Yeah, that looks better. And now I'm going to create another part. So this is 3.5. Yeah, I'm gonna create another part. So 3.5. Just gonna create some shapes here. Go back to that. Say that. Make this to tangent. Make this to concentric. Just keep it like that. Say 10 here. Okay, so I'm extruding that. Maybe just, yeah, about there. And I'm gonna use the same sketch just to extrude it. And I'm gonna select another contour here. I'm gonna extrude it more. And I'm gonna save it as part 4. There you go. So say part 4. And just keep it there for now. So that face are coincident. I'm gonna edit this coincidency because that's not the alignment I wanted. I wanted this alignment. And I know this is not the best mechanically positioned way, but I just wanted to show the actual mechanical mates. So now you can start seeing what I'm trying to do, right? So I'm making a rack, and I'm making a new. So I'm making a rack that pushes another shape right here. All right. So let me just think a little bit more about how I want to do this. Okay, just gonna create something else. I'm gonna create on that plane, make a line. Say I want this line to be 90 or 100, just to have a leaving number. Doesn't matter what's the orientation. I'm gonna create extrusion. I'm gonna say 45 to 45 millimeters, and the thickness of 2 mil. Save it with another name, and import it to my part, to my assembly. So that seems to be too small, so I'm just gonna make it a little bit bigger. let's say 200. You go. So right now, since everything is on that plane, I'm gonna say top plane and line. If I can click on the line, yeah, top plane and line, coincident. That face and that face coincident. And maybe just give it a little bit of a distance right there. So I'm gonna say from there to the line. Well, I just want to make sure the line I choose is the same one. So yeah, from that line to the right plane is gonna be 200, maybe 210. Okay, seems about right. So now as I move this, you see what it's doing? Looks cool, hey? So the closer I come to the line, the more angle is going to do. Sorry, I want it from there to there. And just a 2.5. So now while I move the rack, it's doing that. All right, so maybe I just did it too short. So let's move it up a little bit. As you see, we can change that as much as we want just by dragging. Maybe just this one as well. Let's drag it a little bit farther. And there you go. There's your first mechanism. So I really hope you guys like this video. I know I made some mistakes along the way. I just wanted to make it faster, but by trying to make it faster, I made more mistakes and didn't do what I was supposed to do. Obviously, like I said, as a proper engineer in design, you would need all this to do all these parameters like the pitches and the rack movements and obviously some other design intents here. Like for example, you wouldn't want that to have interference, right? So yeah, I just did along the way what I had to do to fix it, and that took more time than I expected. But this video is about 30 minutes, probably a little bit more. And well, I hope you guys like this video. Let me know if I can make probably a better explanation next time. I don't think there's going to be a second part of this just because I don't want to spend too much time doing pretty much the same as I did before. So next time we're going to go into more mechanical mates, which are going to be probably a hinge. Probably hinge I could have used here. Also, we're going to use a slot, which is a really basic one. The cam, that's a really nice one. The screw, and probably the universal joint. And the advanced mate, we may not do anything else with them. Maybe just a path mate, just so you know what it does. But that's in the future. So I hope you guys like this video. Like, comment, subscribe, and do all the good stuff for more new videos to come. just bear with me for a little bit more. So because I have to make a little bit more tutorials, and once I'm done with those, I'll be making some really good, really cool stuff, like little projects that can be 3D printed and you can use them at your place. Depending on how much time I've got, we can do some certain products or maybe machines or things that can help around the house and just have some automation and engineering fun with each other. So again, I thank you for your patience and I hope you like this video. See you guys next time.